Okay, it's still not working, is it? Okay, so I feel working on. Bismillah. Okay, I hope everyone can hear me. Can you hear me now? Okay, going to continue with the lecture. Sorry, we late about 20 minutes. So what I'm going to share. So if you look at to your, I haven't uploaded the lecture notes on iTalk link. You can have a look, but I'm going to share here as well. Okay. So for to the lecture, okay. We are going to do the humoral immunity too. Continue back to our last lecture. So the key concept that I'm going to have a look is about first the antigen receptor mediated signal transduction in B lymphocytes, T cells in B cells functioning, Ig heavy chain isotype fast switching, and also affinity maturation. So for this one, what we are going to look at, the first thing is about the antigen receptor mediated signal transduction in B lymphocytes. So before I will explain to you like from the naives to the natives of B cells towards until it goes all this maturation. So these are, we're going to have a look at the details about how exactly the activation happened due to antigen receptor. So from here, what we are going to look is firstly is the step from here. So for the antigen receptor mediated signal transduction, we can divide them into 5 steps. First, the cross-linking of membrane immunoglobulin by antigen. Second one, the tyrosine phosphorylation events. The third one is the biochemical intermediates. The fourth one is enzymes, and the fifth one is transcription factors. And here, what you can see is actually about all the 5 steps. First, what happened here? In terms of recognition and initiation, the antigen-specific B cells in the lymphoid follicles of the spleen, lymph nodes, and mucosal lymphoid tissue recognize the antigens that comes from the microbes. So when the antigens reach the membranes there, so the membrane-bound immunoglobulins receptors recognize this antigen in their native conformation. So here they will not do any processing. So just recognize them. So throughout the recognition, as you can see here, just give me a second. So throughout the recognition, what you observe here is actually the cross-linking of immunoglobulin receptors with B cell. Okay, and when they recognize it, they will send stimulus signals that what we call is a tyrosine phosphorylation event. So in this tyrosine phosphorylation event, they will send a further signal that will really activate what we call it the ITAM, the ETAM. So this comes from the protein Ig alpha and Ig beta. And when this phosphorylation event happens, they will activate all the various chemical intermediates. So they got different types of the biochemicals here. You can see we got the PLCY1 activation, also the GTP, GTP action on flats and flat on rats and rat. So here they got different type of enzyme they will produce here, and this enzyme which actually cause all these transcription factors to actually forward to the signaling of T cells later. And here, for your information, that actually the cross-linking will also happen if certain antigen actually can do the cross-linking. The cross-linking meaning here that the antigen actually can affect a couple type of receptors, so which actually can increase further of the antibody production. Okay, as you can see from this is the what we call this primary signaling. So this primary signaling is the main actually when we induced by the antigen, but they also we call it either secondary signals or the second signals caused by the complement protein in B cell, what we call the C3D. So in this C3D, it's actually a protein that causes the secondary signals. So this activation of complement by microbes actually leads to the binding of this complement breakdown of this product of C3D to the microbes. So you can see here, you got the microbes. So when the microbe bound to C3D, it's actually recognized by the B cells here. So we got from the, so it's not just bind to the membrane here, the receptor on the membrane here, but also bind we call the CR2, CD19, and CD81 receptor. So here, in this case, for example, we're recognized by the CR2 receptor. So this receptor is also, so the CR2 attached to, when bound to CR2 attached to the next one, CD19, also CD81. So when this bounds, actually both of these, the Ig alpha or beta and also the CD19, here we actually send a signal, cause the signal to the B cell activation. So here is actually we got another involved of the receptors. So if you compare with the first one, so this receptor is actually involved just the main, the Ig alpha and Ig beta receptors. But for here, we got another one that because it's bound to this another protein C3D, it causes another involvement of receptors, CR2, CD19, and CD81. If you got any questions, you can ask me. So no worries. Okay, and then we look at to the next slide, which actually the functional consequences of the immunoglobulin-mediated B cell activation. So here what I explained last time. So we got the naive B lymphocyte, we got all this proliferation of the cell, and then after the activation. So here you can see here what actually happened. So we got a naive B lymphocyte. So when after the antigen binding and crosslinking of membrane of immunoglobulin happened, it will cause the activation of B lymphocyte. So actually we can divide this into 3 steps. So the activation of lymphocyte, the normally is actually what we call here the first, the entry into cell cycle mitosis. So this is the entry in, so this is what happens when entering into cell cycle and we happen to mitosis. So the significance of these steps is actually caused to the clonal expansion. And we got the second one, after the activation, it will happen due to cytokine receptor. It will increase the expression of cytokine receptor. So this actually the second step of the activation of B lymphocytes. The function is the ability to respond to cytokines which produced by the helper T cells or Th. And I've got a third one of the activation of the naive B lymphocyte. It's actually caused the secretion of low levels of the immunoglobulin M or IgM. So this is actually what we call this early phase of humoral immune response. So here you can see that the change in phenotype or the function of this part is actually cause a low level of GM secretion. So this usually is the first, the primary and activation. It's not the secondary induced, is the primary one. So as I said earlier, the response of this can be greater if the first thing is the antigen must be multivalent. So if the antigen is multivalent, the response will be greater. Another thing is, if the antigen happen to cause the cross-linking, this will cause the response of the B cells to be greater because it's not just bound to one receptor, but it's bound to many receptors. That's what we call cross-linking. And also the antigen can activate complement strongly, which actually can cause the response of the activations higher. So these actually are the stimulation-induced of the early phase of the humoral immune response. So what actually is the purpose of this one? So these are actually what we looked back at the first lecture before. So the first step with the activation from naive to activation, these are the details that I actually simplified in the early lecture. So if you look back here, it's actually that cause not just immediately the antigen bound to the receptor and actually just it's just actually activated, but actually this what detail happens. So all the recognition and we stimulate the Ig alpha, Ig beta, cause all this tyrosine phosphorylations, and then due to the phosphorylation, it will due to the we involve more the production of biochemicals like enzymes and other transcription factors as well. So if you look back, it's actually involved about the cytokine as well. So actually, when we talk about the activation of T cells, of the B cells, excuse me, so it's actually some of them, if due to the protein, it must involvement of the T cells, actually the T dependent state. So what actually the function of T cells in B cells functioning? So the first thing actually where we talk is about the protein antigens elicit as an antibody response. So the efficiency actually about 3 to 7 days of this T cells of antigen exposure. So for once the protein antigen exposed to the B cells, so the antibody response actually it's going to take about 3 to 7 days. So it's about from 3 days to 1 week of the exposure. So during these 3 to 7 days, the helper T cell actually been activated into differentiate into the effector cells, which actually the helper T cell will interact with the antigen stimulated B lymphocytes at the edges of lymphoid follicles. So here, what actually happened is if you look at this one, so how exactly happened interaction between T cells and B cells. So here we got so this is the B cells and this is the naive T cells. So the first thing, so we explained already the antigen recognition by the B cells. So the microbes here, and then you activate the B cell and happen the proliferation and the migration. And here we got the red one is actually the naive CD4 plus T cell. So it's from the lymph nodes. So here, when the T cell, so the microbes actually recognize bound also the ABC bound to the naive T cell, CD4 plus T cell, the T cell will proliferate and differentiate. So what we call it the immigration of CD4 T cells. We got the migration. So the migrate will migrate, so the T and B cell will bound together into receptors. So the easiest way to say about this step is actually you can divide this interaction into 4. The first one we call is independent activation of two cell types by antigen. So the first is the antigen recognized by the B cells, another one the antigen will be recognized by T cell. And the second one is we call it the migration. So the migration of cells towards one another. So one is both of the cells, the B cells and T cells have been activated. And then they will migrate. So it will migrate here out the lymphoid follicle, and here will migrate here. And then this will migrate and interact with each other. And the third one calls as the development of extrafollicular focus of activated B cell, in which in this spot is the part where the early antibody response occur. So when after interaction, they got some extrafollicular focus on activated B cells. And then the fourth one we call is the formation of germinal centers, in which stronger and more effective antibody responses developed. So they got further after the interaction of this one, we can observe further details of the antibody responses. So what the antibody responses, I will not talk detail here because I will talk in what we call the antibody antigen response in the fourth lecture, if I'm not mistaken. So just want to look here the interaction of T cells and B cells. How exactly the interaction if you look in detail? So this is the antigen presentation by B lymphocytes to help T cells. So as I said earlier, so the B cell recognized from the naive B cell recognized the protein antigen, and all the activation happened. We got the receptor mediated endocytosis by antigen steps here. So after the endocytosis antigen happened, the class 2 MHC peptide complex will be expressed on the surface of the B cells. So here, what we call is the antigen processing and presentation. And after this actually that interact with the CD4 plus T cell. So, so the class 2 MHC peptide complex will actually recognize the T cell on the receptor of CD4 plus T cells here. So we've got interaction there. However, if you want to know the B cell, we only recognize the native epitopes, or we call it conventional epitopes, on the CD4 plus T cell. And on the other hand, the helper T cells will actually recognize the peptide fragments of the antigen. That's actually on the MHC peptide complex here. And on the other hand, B cell also can express co-stimulators. For example, B7 molecules, which actually play a role in T cell activation. So here I will move back and forward. So if you look at here again, sorry, if you look at here, so this step, is actually from in details are here. Are details of what actually happened on activation. So, and this step, so that's what we call it simplified here. And then for this one, so the interaction part here is actually the details here is here. So what actually happened before the interaction happened. So during the migration, so that's how exactly it's slides here. So I hope you're not getting confused. So here actually this the combination both of this one and also this one. So we're gonna have a look in details of actually on this tab. So on this part, so we're going to further details on this part, what actually happens. So this is the mechanism of helper T cell mediated activation by B lymphocytes. So, so the image is class 2 will express on the B cell surface. Okay, so here the B cell represent antigen to helper T cell. So the antigen here. So this is T cell. So what happened? The helper T cell is going to activate it to this B7 and the CD28 on the surface of T cell. And then when the CD4 and then when the helper T cell is activated, it will express the CD4 T target of CD cell will cytokines. So it is cytokines. So you got CD4 T on the B cell. So when the CD4 T like recognize the CD4 T here, it will activate the helper T cell and secrete cytokines here. So here, when the cytokines be secreted by the T cell, the B cell will be activated by CD4 T engagement due to the cytokines here. So you recognize the cytokines here, and then the B cells that proliferate and differentiate. So these are the steps that happen here. So just to make sure, so BCR is actually B cell receptor, TCR is T cell receptor. So I hope you don't get confused here. Okay. So after the step here, so the multivalent, so you got questions. So the multivalent is actually, it got many application of the antigen itself. So it's not just have one function of, exactly, so it's actually further function. So you got multiple function of the antigen itself. So that's why you got the multivalent here. Okay, so to the next one. So after the B cell population and differentiation, look at how exactly the B cell, when it's activated, is actually switching class. So the standard one for the B cell, so when it's being activated and recognized, so it recognizes antigen and activated and proliferate, the end, it will be what we call to produce the IgM. So that's the standard one. So it will actually goes to the IgM with complement activation here. So, but on under certain influence of CD4TL or CD4 T ligand and cytokines, after the B cell can actually activate it to differentiate into different cells that actually can produce different type of Igs here. So, as if you look at here, so normally, the B cell will become the will produce differentiate into IgM production of B cells. But due to helper T cells and CD4TL, which produce, we have the CD4TL cytokines, it can differentiate into different type of isotypes here. So here, if the CD4TL and cytokines and also involve of the IFN gamma here, is actually can allow the B cell to switching type to produce the IgG subclasses. with IgG1 or IgG3. So if due to the IL-4 interleukins 4, it actually can switch to the isotype of IgE. The cytokines is actually involved in the production in the mucosal tissue, which actually we got TGF-beta, PFF, and also other cytokines. It actually help the B cells to actually produce the IgA. So from the one B cell, it actually can produce this form. Normally IgM, but due to cytokines, different type of cytokines, you can produce different type of Igs here. So the IgG subclasses here. So the principal effect of this actually if the Fc receptor dependent phagocyte responses, and also it's a complement activation, and actually it's involved in neonatal immunity. So neonatal immunity is referred to the placenta transfer, not the breastfeeding part. And how about the IgE? So the IgE, the principal effector function of IgE here is actually involved of the immunity against helminths. So, and also another function is actually involved into mast cell degranulation. So it's actually we're talking about the hypersensitivity immune response. So this is what that's actually the principal effect of the IgE. And the IgA, because it's actually in the mucosal tissues, so it's actually in the mucosal immunity. So the transport of IgA itself actually is involved through the epithelia. Okay, so that's actually happened. So when we got the B cells activated, proliferate, so but due to different types of cytokines, it can switch into different type of Igs. So either normally IgM, but due to different types of cytokines, either IFN gamma or interleukins 4, or here in the mucosal, it can differentiate. It can go to switching to IgG or IgE and even IgA. So what actually importance of this class switching? So in certain cases, in certain individual or patients, some of them might facing what we call the absence of Cd4 T or Cd4 TL, both on the B cells. So that means that the B cells will only secrete IgM, so they can't really switch to other isotypes. So this kind of individual that facing this kind of problem, they got a disease that we call it as X-linked hyper IgM syndrome. So this syndrome is actually causing that the activating mutation in CD40L gene, which is actually located at the X chromosome. So what happened here due to this syndrome, because it will not produce CD40 or CD40L, so in the serum of the patient or individual itself, the most antibody that will be produced will be the IgM. So because what happened here, due to the IgM, the patient will face defective cell-mediated immunity when it's facing the intracellular microbes. The patient will only have one part of immune response instead of they should have all the full type of immune response. So that means if facing the microbes or the body will not respond to it because of the type of disease. So we do have this disease actually is a genetic disease. So that's why it's really important of this part. So you want that your body of your B cell in body is actually functioning very well, so they can both switch into different type of isotype based on the antigens that respond to the B cell. So if your B cell have some genetic problem, because the X-linked hyper IgM syndrome, your B cells will only produce this IgM instead of IgG, IgE depends on the antigen. So that actually part of important here. Okay, so exactly if you want to look in details, how is the mechanism of the immunoglobulin inhibition isotype switching here? So first we look at this left panel. So on the left panel here, so we got the naive B cell induced the microbial antigen. So if you look on the DNA label here, so this what we call is the rearranged DNA in IgM producing cells. So if there is no signals from the helper T cells, which produce the CD4TL and also the cytokines, it will immediately goes here. We call it transcription and RNA splicing. Here, the VDJ heavy chain gene will be spliced, and then it combined with the exon so the VDJ exon will be combined with the micro exons to produce an mRNA, which included the micro heavy chain that will form part of IgM antibody. So here you got the VDJ here combined with the exon of the microaxon here will produce the mRNA, and RNA will be translated, and that we call it as a microprotein. So the microproteins actually will form into what we call it as the IgM antibody. So the reason why the VDJ joined with the microexons, because the micro gene is actually the closest part, is the closest to the rearranged VDJ unit. It's not just in terms of the DNA arrangement, but because this microexons, the microgene is very close to VDJ gene here. So that's why it's actually joined together. But however, if you look at the center and the right panel, so if you look at the center and the right panel, sorry, I think I missed one. So if you look at the right, the center and the right panel, here what happened, the naive B cell got induced by microwave antigen. If it receives signals from helper T cells, were actually the Cd4 T L and cytokines. So based on different cytokines, it will cause combination with of gene here. So either involving deletion or intervening of C genes and so on. So here, if you look at the center one, is reason for IgG. So what happened here? So this part of DNA is actually being combined, deleted. So the center will be deleted, and the S here and S here will be combined, and this part will actually gamma or gamma gene, and then this gamma genes will actually to gamma mRNA, and this gamma mRNA will be translated to gamma protein, which actually involve of IgG. So in case the same case here, so for the IgE, so this part and this part here, the middle part will be deleted, and half of this one will be combined. So we'll produce another type of combination of gene here. So this combination gene will bound to what we call is the epsilon. We come up with the epsilon exons or epsilon gene here. So it's nearer to this one, and the epsilon gene here will actually be translated to become epsilon mRNA, and the epsilon mRNA will be translated to become epsilon protein, will actually involve in the production of IgE. So how exactly the switching happens? It's not just how actually what the signal caused here in the DNA level. Last part will be what we call the affinity maturation. So once actually we know what actually is it differentiate into different type of here. So it will goes to the maturation steps. So here is actually where the process where the antimatter will be produced in response to the protein antigen. So here, where you can see, so we got the naive B cell, the antigen induced, and the migration, and then we got this what we call this differentiate through the cytokines into different types of subcell B cells here. So here, what we call it, the B cell was somatically mutated Ig5 genes, and IGs with varying affinities for antigen. So it depends. So that's if they become IgE or IgA or IgE or IgM and so on. And then here in this step, what happened here, the B cell with high affinity membrane of Ig bind antigen will mature on the follicular dendritic cells and will present antigen to helper T cells. If you look at the middle, if only the B cell with high affinity membrane Ig will bound to the FDCs, what we call the follicular helper T cells here. So here, this part will bound to the FDC, and the emission class 2 here with the T cell. So, and then it will mature, and then it will recognize on FDC, and then we've got the high affinity B cell. So for the other, here, the other B cell that were not recognized by the FDC, what happened here, it will die here. So only the one actually be recognized by FDC will be selected and survive, and other B cells will die. So just to repeat again, it's quite confusing here. So here you got the naive B cell, antigen induced, migration, and then will be the differentiation, so on. And then if it, for here, the B cell with high affinity membrane, IG, will be recognized by the FDC, so bound to FG, and also by the present antigen helper T cells, and then some of them might not. So for those who might not, what happens when it goes to maturation, it will die. But for those to be recognized or bound to FDC here, it will selected and survive, and yeah, to produce the antibody. So this actually, the affinity measurement is the step where the human or the individual actually be exposed to the repeated same antigen. So this here actually, it can prolong your immune response. So the advantage of this affinity measure is actually the ability of antibodies to bound or to bind to a microbe or microbiome antigen increase if the infection is persistent or recurrent. So meaning that the more your body exposed to a same antigen, I mean, the ability to the antibodies being produced will be increasing due to the maturation here. So this affinity measurement occur in what we call is in the germinal centers. So that's what we call the affinity maturation. So that's the second step, actually the second part of the lecture. So it's actually talk about the details of what we look at in the beginning, where I show you the figure before. So we look at in details how actually activation happens. So like we look back from the beginning. So in this step, we look at in details how actually the naive B cell been activated. So what happened here, the antigen from the induced rebound to the receptor on the membrane surface of the B cells, and due to the induction here, the Ig beta will and then produce what we call tyrosine. We call the process is tyrosine phosphorylation. Due to the phosphorylation, different type of biochemicals involve what we call biochemical intermediates. So it depends. We got the PLC1 deactivation, we also got GTP of. So this I will not talk in details here. You can read it by yourself. I don't want to talk about it. And then due to this biochemical intermediates, we'll produce the active enzymes here. So here we got here from the inositol triphosphate, we'll produce what we call Ca calcium ion dependent enzyme. Here we got the PKC enzyme. Here we got ERK and JNK enzyme. And then what we got transcription factors. So you got NFAT, NFSP here, and also AP1 here. So, but they got another case that actually the microbes are not just to this receptor, the IgA, beta. In certain cases, they got some microbes also what we call the C3D protein. So the C3D proteins actually will bound both by receptors and also the here CR2, and then both of these will actually involve for this B cell activation. Okay, so the activation is actually a T-dependent activation. So here, that what we call involved in the interaction of T cells. So what happened here, the T cells will also be induced by the antigen, the same antigen, both B cell and T cell, and will activate the T cell itself. So when the T cell will be activated, it will proliferate and differentiate and become the effector CD4 plus T cells and migrate. And also here, when the B cell activation, when this produce the MHC class 2 receptor on the membrane, will also migrate and they will meet each other and interact. So the interaction here exactly, if you look at here, it's actually here. So when the microbiome antigens be recognized bound to the receptors here, the receptor mediated will do endocytosis. So in the cytose, the antigen actually will be processed and will present on the class 2 MHC peptide complex here. And this is exactly this class 2, this MHC will bound to the CD4 T cell, CD4 plus T cell here. So if we want to look at this tab, will be this one. So on the interaction here, when the MH class 2 will have the antigen here, will be bound to the T cells here, and also the B7 protein also bound to CD28 T cells here, which somehow will stimulate the the helper T cell to be activated, and then will express the CD4TL or CD4T ligand, which is actually bound to will be bound to CD4T. And due to this interaction here, it will send signal to T cell, helper T cells to secret cytokines, which as cytokine will be recognized and B cells, and then the B cell will be activated again by CD4T engagement and cytokines, and then here causing the B cell to proliferate and differentiation. Okay, and then after all the activation, here the B cell will be differentiated into different, depends on what cytokines been introduced to the B cells, will produce different type of IGs. So here, if it's independent response, so T independent, you will immediately differentiate to produce the IgM here. But if you due to different type of cytokines here, you got IFN gamma, interleukins 4, and also we got the one if in the mucosal tissues. So here we produce different type of IGs, IgG1, IgG3, or which are the Ig classes, and also IgE and IgA. So if you look in detail how exactly is being switching on, so here are the details. So if there's no signal from T cells, immediately the VDJ gene here will combine with the microexons here and be transcribed into mRNA and translate to microprotein, which produce the IgM. So if we got signal from the T cells due to CD4 T ligand cytokines, so it depends on what cytokines here. So the different part of the gene will be deleted and combined here. So in this case, if the center part actually will cause it to produce IgG, and this part to produce the IgE. So if the B cell been exposed to the repeated exposure of same antigen, will cause the what we call affinity maturation, which is have a high affinity of the B cells have to produce antibody. Being differentiated here, if this certain the type of B cell be recognized by FDC, or what we call follicular dendritic cells, and also T cells here, will mature to produce high affinity B cells. The B cell will not bound to the FDC here, and it will also not bound to the T cells here. However, due to the maturation process, it will die. It will not be selected. So this will happen if you be exposed to multiple exposure of the same antigen. Okay, that's what we call the humoral immunity. I will end the lecture today here. Any questions about this, please let me know. You can email me, perhaps because due to rush time and due to we have some technical problem at the beginning of this online lecture, I might miss off some points, or I might say something wrong. So if you need clarification, just email me, or you can just knock my door if I'm in the room. and just ask me questions. I can help to clarify them. So for the next lecture on this evening, it will be normal lecture. I'll go to the lecture hall, which we will continue with, we call it cell-mediated immunity 1. So it goes on the general part of cell-mediated immunity, and then it goes later with the details on the second lecture of cell-mediated immunity 2. So about the antigen antibody response, also for the feedback response, I will explain them in details on the specific lecture where we got the antigen antibody response then with only the fourth lecture. So thank you very much. Sorry for all delays started due to the technical problem. I hope you can somehow understand a little, at least a little bit about this part, this topic. If you have any, if you need clarification, just like I said earlier, just email me. I will help you. So thank you very much. So that's it. So we postpone our lecture to the next one this evening. So thank you.